Oh, it startles me. It's so loud. Okay. Um, all right. Hey, everybody. Good to see y'all. Let me display the agenda. Um,
John, I'm not sure if it's just me, but there's a crackling noise when you're speaking.
Yeah, even I hear the static noise.
all right. Let me try something else. All right. Now I'm talking. Ooh, let me just hang this one up. Okay. All right. How about now? Is that better?
Yes.
Okay. All right. So recording started. All right. So this is work group device management, September 17th. I was going to display the agenda. There we go. Can you still hear me? Okay. All right. So then let's take a look. That's an old one. All right, here we go. September 17th. So just a reminder here, we are looking at just a couple of weeks to finish all of our, at least get the PRR questions, and like 3 weeks to finish all of the caps. And so that's a, time is running out fast. So I wanted to raise these. This is what we've discussed. I wanted to raise it here, make sure that nobody else had other thoughts. I think this was my understanding of the situation. Obviously, we want to graduate to beta. That's top priority. Next top priority is probably this one, at least for Kevin and I. I don't know about anybody else. And then and we can put this down. The other thing, and I'm going to raise this in Signode today too, is we had talked about if we didn't have somebody come forward and with a clear use case and discussion, we would target this for removal. But I would say top priority is beta. Second priority is partitionable devices, and probably this is kind of the order for me, but I'm just one person. Any thoughts?
That's the same order for me, assuming you're moving that one. Yeah.
Yeah, something like that. So looking at those, do other people have other caps they want to? They feel strongly about, and if they do, they probably are going to need to do them themselves. Where else do we stand? Is there anything else we need to track, or is this good to go to Signode with? Because most of these are under Signode, and say this is our target. And do we have capacity to do these things? I mean, that's the other big thing. Design-wise, Antonio and I have been looking at this one because for the networking team, this is higher priority maybe than it is.
I know Lionel reached out to me as well, being interested to write ticket and or at least work with. Lionel, are you on the call right now?
Yes, I could help for this cap.
Okay, awesome. I probably it's going to bring up all kinds of other people. Okay, you'll have to put your other. And then
yeah, I can write it.
Okay, awesome. And then I will also be involved there. So I'll just put myself. Okay. And then Kevin, you and Patrick and Tim and I have had a lot of conversations about partitional devices.
And I can take the lead on writing it. It just won't it won't be able to start till next week, but we've got a lot of material. It just needs to be pulled into
Okay.
the cap.
Awesome. And then Patrick, I know you've already made progress on this.
Yeah, I'll handle the beta graduation.
Okay. Oh, it doesn't. There we go. All right. So then this one, Sergey, this is not this. I'm tracking here. It's not really one we initiated in this work group, but it's one that's relevant to us. And what I don't know if Sergey's here, but what happened in 131 is the device plugin support for this one got put in, but not the DRA support. So I'd like the DRA support to get to alpha in 132 so that we can maybe graduate all of it to beta in 133. Is there anybody in this group who wants to help out? So what this one is taking the device status and making it accessible or making it part of pod status so that people don't have to look and dig around and go spelunking in order to see the status for a pod. So I
can
think
help review.
You'll help review.
I don't
Okay.
know if we're making a distinction between reviewing and authoring.
Yeah. Okay. Okay. I haven't talked to Sergey, and I don't see him on here, so I will follow up with Sergey on that. And then this one is a little bit, I think that the API is going to be a big issue here. Once we have the API, the implementation is probably not too bad because it's essentially just stepping through our scheduling algorithm, and when one fails, trying the next one. So I can probably take the lead on moving that forward and writing the cap since you're doing the other one, Kevin, unless somebody else wants to. I don't want to take over it. And then the last one is this one.
John, Doug has his hand up.
Oh, I'm sorry. I can't see hands. So yeah, because I'm looking at the other screen.
Oh yeah, no worries. It's all good. So question about, and I just brought up the cap, but it's number 4680, add resource health status to the pod status for device plugin and DRA. I'm wondering if this has relevance to the cap we discussed previous to that, the resource claim status for 4817. Is because it'd certainly be a better user experience for people that if they're looking to get that network status, that it be available without having to make a join API wise to like go query for it.
So good question. And I guess probably we need to work with Sergey and maybe with some other, with the API reviewer team and try to figure out what the right thing to do here is. The status that's in the pod is going to just be health. I don't know. I don't know that we want to put, I don't know. It's a good question. Like, do we combine these, right? I don't know.
I guess so. Yeah. My question is this like this status is like propagated to the pod status and not right, which I guess is a little different than like, hey, we'd love you to be able to see this information, right? On the pod, which is probably a more contentious operation than like we're going to propagate something down to an existing status. But it made me think of it, so I had to ask.
No, it's a great question.
I mean, I think the way probably going to be implemented is that there's going to be a new API between the kubelet for the add resource help one. There's going to be a new API between the kubelet and the drivers.
Yeah.
That allow you to publish this information, and the kubelet will then put that in the pod for you. Versus the other one with the resource claim status, the driver will be writing that itself, at least the custom section of it, for the status. It won't be something that will be done on behalf of the driver by the kubelet. So the kubelet, the driver will initiate both, but the path for actually writing this information is going to be different.
Yes, exactly. But the question I think is, do we need the resource
in two
claim
places.
status if we have the other one? It would mean though that like arbitrary blobs of information get put on the pod status. I don't know if people are going to go with that. So I think there's a valid discussion to be had there. We probably need some other people in the room from Signode as well as from API reviews. So Tim, probably Tim would be the best one. I know Clayton has an opinion about this, so we probably want to get some rounds of opinions. It would make our lives easier if we didn't have to do the KEP where the driver writes back to the resource claim, because right now the authorization of that is a bit of a tricky situation. But on the other hand, it seems like stuffing an awful lot in the pod status to like put all these raw extensions that could be anything.
And it's very repetitive. If you have a claim that's referenced across pods, you're having to push the status into however many pods that are sharing access. Versus if it's in the claim, it's about the resources that are bound to that claim.
Right. So, okay. So why don't I'll try and reach out, then I'll take an action here to set up a discussion on Slack and pull in probably Tim and Clayton and who should we bring in from Signode? I mean, I can talk to Don, but is there anybody else, Runal or anybody? And maybe he's on the call. I don't know.
Yeah,
And,
I can participate.
Yeah, I don't want it to be all Googlers, right? There are people in here that have opinions. All right. And others. I mean, it'll be on, we'll arrange something on Slack, but we might have to have a one-off meeting just to sort of sort this out.
Cool, that's super helpful. Thank you, by the way, everybody.
Yeah. Whether I can't type. It should be the same as 4680. It's not going to do it for me. Okay. So obviously, Doug,
just to be clear, it can't be identical to what's in 4680 because the pod doesn't have to reference every device that's in the claim. Whereas the claim should report the health of every device that it's associated with.
okay. So you're saying
this is getting
no, put it in though. Like let's put yeah. I mean the pod. If you're saying if you have a claim that's got 7 requests in it with 8 different, with a bunch of different devices, an individual pod might only reference one request, one device out of that. Sure. Yeah. I think the API allows for that. Right? Yeah. Okay.
Yeah, totally. I do this in some of my examples. Yeah.
Okay. And you can provision claims independently of pods. So, okay.
I guess the point is, I think that we have we have to have at least number 3. Sorry, the third bullet that you have here, we have to have at least the one that you're writing these notes under, because
Yeah.
this is the status of the devices that are associated with this claim. The
Right.
question, I think, is that can that same information on a per devices be propagated into the pod somehow automatically for the devices that that pod references? Or do we actually want a separate mechanism for pushing either the same or similar information into the pod through this new API that we've been talking about?
Right. Yeah, my inkling is that we just want to, my initial thought would be that we just want a health status, right? Like, so one of the proposals
Like one
for,
bit kind of thing.
yeah, for 4817 is that we have a conditions array and we have a state object. And so would be one condition that would be universal across all devices, which is a readiness, I assume, which we use everywhere else. So we would put that readiness, we would propagate that readiness condition, but nothing else. And if you want more details, you go to the claim. That's my kind of initial thought, but we can have that discussion with the broader group. Okay. Awesome. Good. Okay. Okay, so we have the only one we don't have a lead on is the targeting this one for removal.
I anti-volunteer because I don't know if I necessarily agree with this.
Okay, well, I mean, we can have that discussion, right? The discussion we had on the ticket was here. We had a bit of a discussion, and then I suggested that we just, right? We just do it, right? We say, this is the plan. Stop us if you need to stop us. So you have that power too, Kevin. You can stop us if you need to stop us. But we should have that discussion soon if we're going to do it.
Yeah, I mean, to me, it's more just it's a fallback. If we have things we can't do with our API, you could potentially write this third-party controller to do it all yourself. But I also get the fact that it keeps the code base complex, more complex than it potentially needs to be if no one ever actually uses this mechanism. What I'd actually like to see happen is not completely remove this, but slim it down in the sense that instead of saying that you as the user have to define the API for how the controller and the kubelet plugin communicate and then do all your allocations based on that, I'd actually rather see something a little bit simpler that says, no, you have to use resource slices. That is the mechanism to advertise resources. But you could write your own third-party controller to allocate these resources if you wanted.
Okay, so
Rather
what I'm
than
going to do
relying
then, as you said, I will put you on here, and
I think you can already do that. Nothing stops you from writing a controller that exactly uses resource slices, all the machinery that exists elsewhere, but it doesn't change what we have in Kubernetes itself. In Kubernetes, we have to have a pod scheduling context and all the support that comes with it.
You would need to leave the pod scheduling context in place for this to work.
So it wouldn't make Kubernetes easier. We could write additional helper code that makes writing drivers easier, but I think that's not the concern that the Kubernetes maintainers have when they ask for removal of this alpha feature. That is all about the in-tree code.
Yeah, exactly. Okay. So anything else to discuss? My main point is, like, time is ticking real fast. I'd like to get it's Tuesday, like, yeah, we need to get some drafts of some of these out pretty fast. I would think an initial cut by let's see, let me look at the calendar. Oh, I'm showing.
Let's say a week from today.
Yeah, that sounds about right. Yeah. Okay. So goal initial drafts, all of these by, well, that's what the 1 week from today. I should be able to add 7 by the
3
24th.
plus 4, 24.
Okay. Okay, awesome. Any other actually,
I think Sergey joined, but is there any CAP update needed for the resource claim status? The unhealthy one? Sorry, wrong one. The device plugin health.
this one here.
Or is it just an implementation?
I think is Sergey here?
He joined.
Yeah,
So
I'm
the-
driving.
Oh,
Yeah.
okay. So the one about putting the health in the device status, health in the pod status, you did it last cycle for device plugin, but we need to add DRA support. Is it already in the CAP to do DRA support and it's just an implementation thing, or do we need CAP updates?
It's already in a cap, so I don't need to update the cap to do it. So maybe I will just name it Alpha 2 or something. But yeah, this was the idea. Like I wanted to understand how to do it, basically.
Okay. Okay, well, that's the one thing we got your name on. So you and I can follow up with it later if you want.
Thank you.
Okay. I see some things in the chat. Okay. All right.
Yeah, is there an issue specifically looking at resource slices status? Is that a thing?
I don't think we have an issue for that right now. Do we, Patrick, has something been raised? Because I see, Rita, you put something in the, you had to restart the NVIDIA device plugin pod.
Yeah, so
That's when-
so the use cases, even I love the resource claim status because that's how you can tell, right? After it's scheduled. However, when the devices becomes actually available, the claims would just be pending and like the pod, right? Because it can't actually find the the devices. And this is particularly reproducible with the MIG partition configuration. By the way, Kevin, you did a great job. It was awesome. The plugin you wrote, and thanks for the help on on GitHub. And I don't know if it's because there's an issue with the NVIDIA device drivers or whatnot.
No,
but
there's a known bug. Actually, this sounds like the bug that we can't backport because it doesn't meet criteria. You know what I'm talking about, Patrick? So there's an
Restarting a
issue-
driver is problematic if a claim is pending and when a pod is pending and when you start the driver and resource slices become available, the scheduler doesn't react. So that is a known bug. John suggested that we should document it, but I don't know where. Known issues is, I don't know. Should it go in the documentation of a website? Would people find it there? I don't know.
to reads documentation, right?
Yeah.
I mean, it can, yeah. Rita, where would you, if we had documented that bug, where would you have found? Maybe in the NVIDIA README. That might be where people are more likely to find it.
same bug, if that's okay. Because in this case, resource slices already got created, right? So it thinks there's enough devices, but let's just say for whatever reason make config changes on the host, right? It doesn't actually get propagated to the cluster.
That's just because I haven't written the plugin to recognize these. So the NVIDIA device plugins was originally written assuming it itself would dynamically create these MIG devices. but because we don't have support for partitionable devices in DRA yet, we have to
Okay.
statically create these devices. And I haven't updated the logic in our plugins. You say, oh, if someone does this outside of the plugin, and the plugin doesn't notice that unless you restart it. It's just the way that it's written currently. I think this is what you're getting at, is that if
Yeah,
you had the NVIDIA driver running, you then create MIG devices, the NVIDIA driver doesn't suddenly make these available in the resource. Yeah, that's just because it doesn't know to do that. The logic could be written for it to do this. It just doesn't, and it's kind of left over from the standard device plugin. We have the exact same. I wouldn't even call it an issue. It's the way it's designed. The idea is specifically this: if you change the MIG configuration, you need to restart the device plugin. That's what we do today, except that it doesn't force you to do a pod deletion and restart. You can send it a SIG-HUP signal, and that'll trigger it to reload. But in theory, it could, watch the file system or do something else to discover that MIG devices were created and then re-advertise these, which is not the way it's been written. But in addition to that, the bug that Patrick and John just mentioned, that is, unless we had a way for it to automatically figure these out and push the slices back up with new additions, it sounds like, correct me if I'm wrong, John and Patrick, it wouldn't actually recognize these changes, or is that not correct? What is the bug again? Can you...
Patrick can probably describe it better. I don't. It's
If
like
if a pod is pending and resource slices change, no matter how they change, the scheduler will not
Right.
notice that, and the pod remains pending. It should
so
eventually
it's about the
it should
pod
it should
so that
it should get scheduled after, I think, 5 minutes or so. But there's a default timeout that an unscheduled pod gets retried, but it's still bug.
Mhm.
okay.
Right. So I guess the point is that if you have your pod running, if you have a pod running that's asking for a MIG device, there's no MIG devices on the machine. Our driver's sitting there, waiting for MIG devices to show up. You then do some reconfiguration, create the MIG devices. Even if we wrote this logic for the driver to automatically pick that up, update the resource slices, that pod's not going to be scheduled, it sounds like, for at least 5 minutes because of this bug. But the exact bug that you're talking about there is an artifact of just, I didn't write this into the NVIDIA DRA driver to be able to pick up
It's just
MIG
intended
devices
to be
created
static.
on
Yeah.
the side. Yeah, it's
Right.
So,
intended to be
Rita,
static.
what we have, the partitionable devices thing we've been talking about, is specifically to do dynamic MIG. So the idea would be that the resource slide, the driver would advertise all the possible MIG configurations, and then the claim would get assigned one of those that meets its needs, and then that actually would sort of eliminate other devices from consideration because of that change.
And then the point is that the driver itself would then create this MIG device. It doesn't need to look and discover what you've created, back on the host. It's going to create it itself. So obviously then know about it. But it also doesn't need to update the resource slice at that point because it's already advertising it a priori as something that it has the ability to create later on.
Right.
Does that answer your questions? Rita?
Yes, sounds like in order for the dynamic aspect of all this to work, it sounds like the device plugin needs to be aware of the changes on the host, and the resource slices need to be updated by the device plugin, right? And then the scheduler will need to recognize the changes in the resource slice in order to assign new devices.
You're talking about in 131. So in the current version of Kubernetes, because in the next version of Kubernetes, assuming we get this kept completed,
Mhm.
none of that will be necessary anymore based on what we just said. Because you will already pre-advertise all of the MIG devices. You won't need to create them outside of the DRA plugin because it will create the MIG devices on the fly based on what's requested and what's been bound to the claim. But in the current version of Kubernetes, these APIs don't exist, and so we're supporting a mechanism that's similar to what we support in the existing device plugin.
So Kevin,
Configuration can change, right? So unless the the MIG configuration can change on the host. So everything needs to be able to detect that.
So I think that
So
there's two.
in the next version of Kubernetes, you cannot be changing MIG configuration. The DRA driver has to own that and what MIG devices get created, because it will create them and destroy them on the fly.
So I think there's two things, if I can maybe try to bridge the understanding. Okay, in 131, and what will go to beta 132, so what would be actually like out there in real clusters, it's the driver advertises whatever MIGs, and correct me if I'm wrong here, Kevin, what I'm hearing is the driver advertises whatever MIGs are created at the time it starts. And those are treated just like any other device and can be accessed and allocated, or can be allocated like any other device. It doesn't today reconcile out of band changes to that MIG configuration, because the expectation has always been that it's within the control of the, like, it's sort of static. It's the way the device plugin works today. It's static at node boot time, and it's like it shouldn't be changing. In order to make MIGs,
If it does change, it needs to be done in a very controlled way. And we have, at least in the ecosystem that the NVIDIA components have for the GPU operator, you can orchestrate the changing of the MIG devices, but it's done in a very controlled way. You set a label on the node, and this component called the MIG manager kicks in, and it will make sure all of the things get shut down, including the DRA driver or the device plugin or whatever. It takes them offline on the node. It then reconfigures MIG for you, and then brings them all back up so that they discover those changes as they come back online. That's how MIG today is orchestrated with the device plugin and everything. And in the DRA world, with static MIG, it would work exactly the same. But in 132, once we have support for professional devices, you don't need the MIG manager anymore, because the DRA driver is going to dynamically manage these MIG devices for you.
right?
Yeah.
But that won't hit real clusters till 133 if we're lucky.
I see. So we assume things don't change outside of the device plugin, right? Okay, that's much clearer now. And I'll take a look at the partition cap that you guys been talking about. Sounds interesting.
Okay, thank you. Sergey?
Yeah, with this change that we're talking about, will we need to update some pod resources API? So this gRPC interface will return. Like, I'm not sure even which device it needs to return in pod resource API in this case.
Oh, you're
So
going
we
back?
have so for one, you mean for the partitionable ones, or?
Yeah.
It should be the same. So pod resources API, the way we update it is that I don't remember the exact structure, but it has a bunch of information. It has the name of the device as advertised by the resource slice. It has what claim it's been bound to. It has what resource class it's associated with. It has a bunch of information associated with it. And as I mentioned before, in this new partitionable devices mechanism that we've been discussing, it's still going to be a flat list of devices. You're going to have full GPUs listed right next to MIG devices, right next to anything else that might potentially be allocatable. But there will be things encoded in there so that the scheduler knows that some of these things overlap. So that if you allocate this full GPU, all those MIG devices that are also part of that are no longer up for grabs for you to have bound to a claim. But from the perspective of the pod resource API and what a device looks like, and then will eventually be propagated out over the pod resources API, it looks identical for a MIG device or a full GPU or whatever. Does that answer the question?
The pod resource API will return more devices than exists, right? Also shapes of those devices.
Sorry, I didn't understand. Can you say it again?
I'm curious if pod resources API will return all the shapes of the devices, or it will only return shapes that actually being used, being claimed for.
It will return so it will return the set of resources that have been referenced by this claim and consumed by some container that's associated with it.
Oh, I see. Okay, thank you.
Yeah, I guess also it'll be actually be any of the, I take it back. It might actually return all of the resources that are part of the claim, because I think we need the network resources advertised there as well. And we talked about potentially including those even if they're not referenced in any container.
Yeah.
I need to look at what we actually do there.
So Kevin, one thing we do need to think about as we look at the partitionable one is, I think the question Sergey is getting at is how, like, the scheduler knows these overlap, and so the scheduler knows not to consider these for other things. How does a user know that they've been, like, if a user wants to say, go and just say, what are the GPUs on this node, and are they in use? I guess we already don't have that recorded in resource slice today, do we? We just have capacity. We don't record the allocations anywhere. I mean, we record them in the
You
claim.
record them in the claims. You have to,
But no.
you have to cross-reference the
Yeah.
up and bound for the different pods. And
Okay,
what
so that might be a
claims are-
usability thing we
they
eventually want to get to, yeah. But
Yeah, it's not easy to discover, at least currently, what is the real-time set of devices that are allocatable right now.
correct, yeah. The scheduler kind of constructs that view in memory.
But it's true for the device plugin API today too. The only thing you advertise with the device plugin API is capacity and allocatable. But allocatable is not real-time allocatable. It's basically healthy devices. But there's nothing unless you go and actually look at the pod resource API and add up the resources across that and cross-reference with what's available. There's no way to discover what's consumed and what's not.
So it's no worse than today.
It's no worse than today. I guess you could look at what's assigned on the notes. But yeah, it's no worse than today. You still have to, pull together information from multiple objects.
Okay.
to get to it.
All right. Well, that's a new feature. If we want to change it, it'll be a new cap. Okay. All right. Then before we move on, any other questions we have? I think Kevin has some additional. I stopped sharing the agenda. I can share it again. So we've put people's names against these. We have a goal of 1 week from today. There's a bunch of things listed lower in this document. I in theory, I should go create enhancement issues for all those, but since they're not, none of them are happening in this release, I haven't taken the time to do that. That's what this item is here. Before we move to Kevin's
Patrick
item,
has his hand up.
Patrick
Patrick has his hand up.
Yeah. One question about promotion to beta of a core functionality. Do we as a group consider cluster autoscaler support as a blocking criteria for going to beta? We've been promised that it would get implemented this cycle, but I've not heard anything about that. I can certainly ping.
Talk to Kuba
Yeah.
about making sure he's got room, and I will work that internally here. I think my goal is definitely to make that happen. So
it's
I know that's
really
not your question.
it's really a question about what I should put into the cap update, because I now need to define the beta criteria, and if we promise to do cluster autoscaler and then don't deliver, it'll block beta. Perhaps that's what it should, but I'm not sure. It's
Kevin,
really
it
a
looked like you
question.
were talking, but you're muted.
Oh, sorry. I just said, then it sounds like you should just leave it out until someone complains and says, hey, why isn't cluster autoscaler?
Yeah.
That's probably a good idea. Just leave it out for now. I'll sync up with Kuba. I'll sync up with the cluster autoscaling team here. But like that SIG needs to be like, no, this needs to be in here in order to like let's yeah.
My position is that there are enough people who don't need autoscaling that it is worthwhile to promote to beta. In particular, now that we are in a state where it should be doable if someone cares enough. But yeah, I can also understand people that are saying that we need to prove that it can be done first because there might be something that we overlooked. So yeah,
Even
see
if
both
what we
sides.
said, I would be more comfortable with, we have alpha support for cluster auto scaling, but we take the main thing to beta, because that tells us at least like we didn't make some drastic design error that makes cluster auto scaling not work. So, but let's leave it out for now. We'll sync with the cluster
Okay.
auto scaling folks. Thank you, Patrick. Okay, Kevin, you want to take over?
Yeah, sorry, we need names. Too many Kevins on this call, surprisingly.
It's rare. It's almost never multiple Kevins.
Oh yeah, you're right. Sorry, Kevin Hannon. Yeah.
No, I get you. I was just a brief update. The last bullet point, I don't know if that, I don't remember putting that one. So I don't know why it's assigned to me.
Okay.
Abhishek, did you add that by chance?
Nope.
I think it was in your comment or something that I accepted a couple of weeks ago, and so I just put your name next to it. But maybe, yeah, whatever. We will discuss that in the cap. That looked like.
Yeah, I just wanted to say that I'm looking at trying to build a feature in Q for supporting structured parameters. I've drafted a KEP in Q, and I was going to kind of I've been working on that in the next few weeks to try and make sure that DRA can work with Q. And so I know that Kevin has some, there were some talks about redesigning how quota management would work with DRA. I'm kind of going to go ahead with structured parameters as the main support for now, since that our goal will be that we'll hit beta in 1.32. Fingers crossed. And it'd be nice to have some support for Q in that one.
So this is an interesting question. So one of the debates around resource quota is admission time versus allocation time, and there's pros and cons to both. And I would be curious to hear whether Q has an opinion on this, right?
I did open up a draft PR, at least from a very simple design from Patrick, kind of. I mean, we're going to put quota limits on device classes, and then when a queue emits a workload, we're going to read the claims and kind of correlate that to how many requests to the device class there are, and then kind of block admission of a workload. Queue works at the scheduler level. It's not about any kind of capacity. Like I found an interesting problem with Q where if you don't have any if you don't have any pod requests, Q will emit your workload because it doesn't know. It doesn't know what's actually being used. So I think this will be scheduler time. I guess it will be enforcing it before the workload is actually emitted.
Right. And so what the question is about the feedback loop. Like the question I would have is, okay, so if we do it at allocation time, which based on some of the features we're talking about, it's likely we're going to have, it seems likely like the one of, right? Like that, you can't do it at admission time because you don't know until schedule time which one you'd count against quota. Like the preferable list, prioritized list functionality, or I can satisfy the same claim with multiple devices, one or two, like I don't think that's on the list for 132, but maybe someday we'll do it. Again, that can't be, you don't know the answer until you do scheduling. And so you don't know the quota consumed until you do scheduling. And now you don't know it at admission time. So what is the feedback loop then to Q? Because Q couldn't evaluate up front, or it has to evaluate worst case and say, okay, you've got 3 things listed in your prioritized list, so I'm going to count it as you have to have quota for each of those in order to admit. But that kind of sucks because, right, like the point of putting it in a list is you want to pick the one that can satisfy it. It kind of defeats the purpose. So you said something a second ago about Q doesn't know does Q track the quota itself, or does it read the quota consumption stats out of the cluster, I guess would be one question.
So it will essentially, you can think of it like a job where you'll schedule a job or you'll create a job, and then Q will read the resources, the requests, and then I think it will say that is your usage. And then it will determine whether or not it actually has the capacity on your cluster at the time when it's emitted, if that is available. And then it will emit your workload, and then it will go to schedule. And then the scheduler will actually, or then you will find the right node for the workload, for the
Right.
pod, or for the job, for the pod.
So all of these features that create a fuzzy request are going to cause trouble for Q, much in the way they potentially cause trouble for our standard resource quota. So we kind of like dumbed it down for 131 and for the beta, where we don't have any of that stuff, I don't think. And so we can do it by device class, and it's fairly simple, but there's some real work here to sort out how we want to do this properly. So I would ask Kevin that you, keep us, like, let's work together on this and reach out on the work group device management channel. But we do have Patrick, in the 131, in the beta code, the cap to take things to beta, are we doing anything else about resource quota? I seem to recall us talking about.
No,
Okay, we're not.
I think we decided to just go with what we could implement at admission time, and that will be what we promote to beta.
Okay.
A quota at scheduling time would be another cap.
Okay.
And Kevin Cruz asked me about that, because it is indeed the main use case for GPUs, that you want to limit memory usage, and that's not well suited to the device class based approach that we have right now. So there is an interest in a better quota mechanism for real world scenarios, and we don't have a cap. I don't think we are planning one for 132 either, but it is something that needs to be done at some point.
It's not on that list, but it is. I think you or Kevin created an issue for it. I saw recently.
I did. I created an issue because we talked about it, but it wasn't being tracked anywhere. It's not an enhancement issue though. It's just or is it? Yeah, it is an enhancement issue.
I think it was.
But there's no talk of putting a cap around it. It's not assigned to anyone. I just didn't want to lose track of it. Unless someone wants to volunteer to pick it up. Yeah.
Okay, because we're gonna have to. This is going to be part of the discussion. I see your hand, Abhishek. 1 second. This is going to be part of the discussion when we talk about at least the prioritized list one, Kevin Clues, right? We're going to have to understand this quota issue better. Okay. Thank you, Kevin, for raising that. Like, let's definitely, anything we can do to support you getting this in queue, please reach out.
Yeah, hopefully in a few weeks I can give a demo of it. I'm gonna try and at least get a quick, easy POC with this done before I continue on the queue side.
Awesome, thank you. Abhishek?
Yeah, I have two questions. So you mentioned the DRA machinery creating fuzzy claims. Can you expand a bit more on that? And the second question is, I mean, maybe Q is step 2, but what is our path of integrating with Kubernetes quotas and DRA?
So what we've done so far in Kubernetes quotas is a device class based quota. So the administrator can say, in this namespace, you're allowed 5 devices of this device class. And that's it. That's all we have right now. And what the issue that we were just talking about is, and Kevin put an enhancements issue where we can add a cap, is better, right? Like, can we say this namespace can use this much GPU memory? Of course, then we have to have a way to define GPU memory, which we have in this capacity field within the claim, right? Within the resource slice within the device. So, but the problem is we have one of the problems we have is what I mentioned, this fuzzy claim. So if you look at some of these things that we're talking about. In particular, one we are talking about doing in this release, which is this one, but other ones like this one. And then, yeah, here's that. Okay. So these two in particular, and there's probably others. What I mean by a fuzzy claim is they create a claim that's trying to say, it's trying to allow flexibility in how the claim is met. So one of the one we want to do alpha in this release is this prioritized list, which would basically say, I write a claim and the claim has a couple of requests in it, but the requests are you only satisfy one of them. So my first preference is an H100. If I can't get an H100, give me an A100. If I can't get an A100, give me two L4s. So, right, but look at that. Those are three different device classes potentially. They're also different counts. So from a quota perspective, how do I manage that, right? If I do it at admission time, the only way I could do it would be to count that against all of those quotas, which might make it inadmissible. And the whole point of the prioritized list is to be able to satisfy it based upon what's present in the cluster and available for your quota and available for whatever, right? Real-time allocatability. So that's when I say we have a fuzzy request. That's one way. The other way is that other one, which is like, well, I'm going to be even vaguer than that. I'm just going to say I need 100 gigabytes of GPU memory. Now, if you can give that to me in one big device, great. If you need to give me two smaller devices, fine. If you need to give me 8 smaller devices, I'm even okay with that. You could set the range like 1 to 3 devices, 1 to 6 devices, whatever it is. And again, that's a fuzzy claim that won't be decided until scheduling time based upon real-time availability in the cluster. So at admission time, we don't have a way to manage the quota. We can't manage the quota until later. And so with something like Q, building on top of quota, how does it manage that, right? But even a regular user, how do they understand quota? So these are the big questions we just don't have any good answers to right now, which is why in 131 and 132 beta, we're going with the simple device class at admission time, but we know that's not sufficient to do some of the things we want to do, and we haven't figured it out yet.
Okay, yeah, thank you. So going back to the Q quota integration, the static, 5 devices class for a namespace that you specify, maybe this works for whole GPUs of a kind, but it still has issues with partitionable devices, right?
I would think so. I mean, except that, I think we're gonna. So Kevin Clues, I gotta clarify here. Fully namespace these names. In your plan, are you gonna have like just an NVIDIA device class? Are you gonna have like a one per model? Are you gonna have one for MIGs and one for physical? Like, what is your thinking right now? And maybe we don't have, because I know at one point we had talked about you have some things where you can do today. You want to be able to say, give me a physical device if one's available, fall back to a MIG. Like, we haven't implemented that. So what is your planning right now?
I actually, I don't know how to do that. So what you just said in structured parameters, it was very easy with, and we had it implemented support for that with the classic DRA, because we controlled the API. And so we could, even if we wanted to, we could translate that API into some complex cell expression, which you could still do now. You could write a complex cell expression, but it puts this burden on the end user now to write all of that out. But yeah, so I think the idea for that would be that, so this is what I've done in the existing implementation so far that I updated to 131, is I have 2 device classes. I have one called gpu.nvidia.com and one called mig.nvidia.com. Okay. Those are my 2 device classes. And gpu.nvidia.com says, give me a device from driver equals gpu.nvidia.com, and type equals GPU. So I've created an abstract type that I attached all of my devices to kind of categorize them into different things. This is a GPU versus this is a MIG. And then, yeah, the gpu.nvidia.com device class has to be of type GPU, and the other one has to be of type MIG. What I don't know how to do, at least not easily, is have a device class that says, give me either or, but prioritize GPUs. Or prioritize MIG, depending on what you want. Or enforce that, and this is a big one actually, enforce that if you ask for a MIG, you only get one, and you're not allowed to ask for more than one. Again, because in classic DRA, we controlled the API. I had a specific claim parameters object called, MIG claim parameters object, and you couldn't put a count in that. You had to say what profile you wanted, but you couldn't specify a count because CUDA only knows how to do anything with one of these MIG devices. If you give it more than that, it just ignores the other one. And so you didn't want to have it in the API that you could ask for multiple ones now. Because the count is a part of the top level claim at this point, there's nothing preventing someone from referencing device class mig.nvidia.com and then asking for 5 of these. And scheduler will gladly give you 5. The plugin will gladly inject all 5 of those into your container, but CUDA is only going to be able to make use of one of them.
Well, you said that future versions of CUDA might be able to make use of more than one.
Yeah, in fact, there are drivers, yes, you can already, but not in any release drivers. So yeah, in newer versions of the drivers, we'll be able to do this. But
do you have this captured anywhere in an issue? Because we could lose track of it easily if we don't. Because there are things we could do in the API. We were talking about prioritized list. There's other or there's things we could do. Maybe there's cell expressions that drivers can publish that the scheduler can evaluate under certain circumstances. But we're
so what I was about to say, I think that, okay, sorry, yeah. Just the final thought on that is if we had the one of mechanism, then someone could encode, give me a full GPU, if not fall back to a MIG. And then that could be a one of prioritized list.
Painful for the user. So then there's questions of whether something should show up in a device class and how much expressiveness we want to give device classes. Abhishek, you get the last word.
Yeah, I mean, I was just saying, this machinery seems complex, and quota management is important for like having this a real multi-tenant system, right? So we should have a document and put our thoughts on what we think the user can do. It's not about implementation. We want to see what the current design supports, and all I'm asking or all I'm voting for is cube quota integration, and step 2 could be queue quota integration, like if we all agree.
And the cube quota integration is the simple device class count right now at admission time. That's what's going to go to beta. That's what Q can support too. It's when we get to these more sophisticated use cases, which we don't have in the existing 131 API, you can't do these fuzzy claims, that we need to figure it out. So I appreciate that. Yeah, awesome. Thank you, everybody. We're out of time. I'll see y'all next time.
Bye-bye. Thank you.